Hi everyone, my name is Elisha Sengupta, and in this video, we will be discussing units and irrational numbers. So to begin with, a few very basic units that we have all learned in our previous grades are meter, liter, and gram. And a few prefixes that I'm sure you must be familiar with is deci, centi, milli, deca, hecto, and kilo. An acronym that can help you remember these prefixes is King Henry died unusually drinking chocolate milk. And unusually is where you insert your unit of measurement, which is meter, liter, or gram. So moving on to irrational and rational numbers. Rational numbers is the ratio of two integers. So it's a ratio of two simple numbers. It's a simple ratio. Uh, so for example, 1.5 is a rational number because it can be represented in the simple ratio of 3/2 or 6/4 and so on. 7 is also a rational number because it can be written in the ratio of 7/1, 14/2, and etc. Now, 0.333, although it may look like an irrational number because it's a recurring decimal, it can also be represented in the simple ratio 1/3. Another way to represent 0.333 is just 0.3, and we put a bar on top of 3. So the bar tells you that the number is a repeating number. So in this case, 3 is the repeating number. Now, what is an irrational number? An irrational number is a real number that cannot be written as a simple fraction. So a few examples of irrational numbers is pi, Euler's number, the golden ratio, and a few root numbers. Now, the value of pi, we approximated to 3.14, but in reality, the number is much longer than that. So it is around 3.14159265358, and it keeps going on like that. Similarly, Euler's number, although we say that it's 2.71, it's much longer than that. It's 2.71828, and it keeps going on. Now, by some root numbers, I mean that any number that is not a whole square. So for example, root 2 is an irrational number. However, root 9 is a rational number because it can be simplified to 3/1. Now, so with all of this, let's move on to an simple exercise, which is to identify if these numbers are rational or irrational. So to begin with, is root 3 a rational number or an irrational number? Now, like I said, 3 is not a whole square, and hence the root of 3 will not be a whole number. So root 3 is approximated to 1.732, hence it will be an irrational number. Now, the next sum is, so let's just simplify this equation in simple terms. So that's 10 plus 9, and root 16 can be written as 4 because 16 is a whole square. Now this equation can be simplified to 10 plus 36, and 10 plus 36 is 46. So since we're getting a whole number, this will be a rational number. Now for the third sum, the value of root 11 and the value of root 3 cannot be represented in a simple fraction, and the addition of two irrational numbers will remain an irrational number. So root 3 is an irrational number, the second sum is rational, and the third sum is irrational. So we see that we've gotten all of these correct. Now moving on, for the next exercise, we will learn how to rationalize the denominator. And one common identity that we will be using is this one. So I'm sure you're familiar with all three identities, but when it comes to rationalizing the denominator, simplifying it into rational number, this is the most common identity that we use. So this is the sum that we've been given. I will pause the video for 3 seconds. Feel free to pause the video if you need more time, and then I will display the answer. All right. So this is how we're going to work with this sum. So like I said, to rationalize a number, we have to first rationalize the denominator. Now we can see that the denominator is an irrational number because √3 minus √5, they're both irrational numbers, and it will also result in an irrational number. So we're going to rationalize this number by using the identity that is displayed on the board here. A minus b into a plus b gives us a square plus b squared. So what we've done is this is a minus b into a plus b. So if we multiply the denominator with a plus b, we also multiply the numerator with a plus b. Now this identity is what is being displayed here, and the denominator becomes a square minus b square, whereas the numerator, it's a plus b into a plus b, which will, once expanded, will give you a square plus b square plus 2ab. So that's a square plus b square plus 2ab. Now, once these two equations are simplified, we arrive with 8 plus 2 into √15 divided by minus 2. Now, once you divide both the numerator and denominator with minus 2, we end up with the answer minus 4 minus √15. So that's how we solve a simple rationalize the denominator sum. Let's do one more to clear the understanding. So again, this is the sum. I will wait for 3 seconds. You can pause the video if you need extra time. All right, so we're going to use the similar method of first rationalizing the denominator. So since we're given a plus b here, we're going to multiply this with a minus b. So if the numerator is multiplied with a minus b, we also multiply the denominator with a minus b. Now that's a plus b into a minus b, and we use this identity. It gives us a square minus b square. So that's a square minus b square. Anything multiplied by 1 is the number itself. Now, once this number is simplified, we result in this. We take out 2 common. We divide both the numerator and denominator with 2. And this is what we arrive at. So just go through this sum and make sure that the concept is clear. Right. So just summary of what we've learned today. We learned the units of measurement and an acronym that has been proven to be extremely useful is King Henry died unusually drinking chocolate milk, which is deci-centi-milli, deca, hecto, kilo, and unusually is the units that we insert. We also learned what an irrational number is and what a rational number is. Rational numbers are numbers that can be represented in a simple ratio, and irrational numbers are numbers that cannot be represented in a simple ratio. We learned how to rationalize the denominator using an irrational number. We learned how to make use of the identity a plus b into a minus b gives you a square minus b square, and we learned how to solve these kind of sums. So that's all for today. I hope you guys have learned something new, and thank you for watching.